OK, this is our very first internet protocol. And we'll talk about how it works. Then we'll talk about attacks on it. So far, we've shown that there is layer 2, where machines get connected in a local network, and layer 3, where the local networks themselves become connected in a so-called network of networks model. So it's a network where every node is one of these local networks. That's what layer 3 looks like. Now, one problem we have is that at layer 2, we use MAC addresses. MAC addresses are good because they identify hardware components, but they're not useful at layer 3, where we need global addressing. By contrast, at layer 3, we use IP addresses. These are useful at layer 3 because somewhere in those numbers, they tell us where the host is located. But they're not so useful at layer 2, where we need these hard-coded MAC addresses. Now, exactly why we need both of these is a little bit beyond the scope of this class. But the punchline is that layer 2 identifies devices using MAC addresses, and layer 3 identifies devices using IP addresses. So in other words, there are two different addressing systems. So one problem if you have two different addressing systems is that sometimes you'll want to convert between one address and another. So let's say that Alice and Bob want to talk to each other, but Alice only knows Bob's layer 3 IP address. Now, if she wants to use a layer 2 protocol, she would have to know Bob's layer 2 MAC address as well. So even though she knows Bob's layer 3 address, she doesn't necessarily know Bob's layer 2 address. So we're going to make a protocol that allows users to translate layer 3 IP addresses to their corresponding layer 2 MAC addresses. And that protocol is called ARP. And it works like this. Here it is in text. Let me show it to you in pictures. So here's Alice. So far, she doesn't know anything. So she doesn't have any mappings of IPs or MACs. And she wants to know Bob's IP address. Or rather, she wants to know Bob's MAC address given his IP address. So right now, her cache is empty. She does not know the answer to this question. And she also doesn't know who to ask, because she has no idea what's going on. So what she'll do is she needs to figure out where Bob is and figure out what his MAC address is. So what Alice is going to do is the simplest thing she can think of. She doesn't know the answer. She doesn't know which of these is Bob right now. So all that she can do is broadcast a request. And broadcast means sending it to everyone. So she will broadcast a request. And the request says, does anybody know the MAC address corresponding to the IP 1.2.3.4? Who knows this answer? I'm going to ask everybody on the local network in the hopes that someone can tell me the answer. Now, what should happen is when Bob hears this message, Bob's going to think 1.2.3.4 is me. So Alice is asking me for my MAC address. So Bob can reply directly to Alice and say, my IP address is 1.2.3.4, and this is my corresponding MAC address. So Bob replies with the answer. Everybody else is not Bob, so they can just ignore the request. And at this point, Alice knows the answer, so she can put that IP to MAC mapping in her cache, so that later, if she has the same question, she remembers the answer for some time. So this is what ARP looks like if done properly. When Alice doesn't know the answer, she asks everybody, and Bob, who does know the answer, will reply with his IP to MAC mapping. Now here are some little footnotes about how ARP works. If Bob was somehow not inside the local network, for example, Alice wanted to know Bob's MAC address, but Bob is somewhere really far away in a totally different network, then what usually happens is that the router will respond and say, Bob's not here, but if you want to talk to Bob, you can send a message to me. Here's my MAC address. And then the router will forward the message to Bob. So if Bob was somewhere far away, Alice still has to broadcast the same question saying, who knows this MAC address mapping? And the router will notice that Bob is not in the local network, will reply to Alice with the router's MAC address. And then the packet will get forwarded to the router. And then the router will send the message onwards to Bob. Again, the exact details are not what we're here for, but that's what would happen if Bob was not in the network. And one final little footnote is that sometimes you'll get unsolicited ARP requests. So sometimes, even if you don't ask the question, someone might just walk up to you and say, here's an IP to MAC mapping that I think is useful. And if you receive one of those, you can cache that as well. So I guess here's a picture of all the headers. You'll notice that at layer 3, we have the IP header. This is your global address, and this is the destination's global address. And then here you have your local address at layer 2. And then this is either Bob's local address, if he's also in your network, or the router's local address if Bob is somewhere else. So that's the router's MAC address. That's Bob's IP address.